And we're live. Welcome, everybody. I'm super excited. This is our third talk for the day, and we're ending the week on such a strong note. We have the DeFi, the Crosschain DeFi extraordinaires from Acala joining us today. We have Ruitao and Bryan Chen with us, and we're going to talk about DeFi, the very hot topic of DeFi. But before we do that, I like to get to know our participants, our presenters a little bit better and have a bit of a chat with them. So I've been asking everybody that joins us on the stream, what was their like aha moment? When did they get into blockchain? Why did they make the jump into this crazy, harebrained scheme of blockchain? And yeah, who wants to go first? It's not often that I get to interview two people at the same time. Let's start with Bryan.
Yeah, so it's a very blockchain is definitely a very interesting industry. Yeah, I've been actually first heard of Bitcoin very long time ago, like while I was at university. But it's one of my biggest life regrets that I haven't actually paid too much attention to it. It's a time when people can still mine Bitcoins on the personal computers. I've like actually before that I've down a similar project that you run some software on your computer and earn you some money, but it ended up I figured out like the payout doesn't worth the electricity cost, which is true by the time when Bitcoin is inverted, like the payout is not worth anything. But unfortunately, I didn't forecast because the coin itself, the value can increase that much. So yeah, then after a while, then I revisit Bitcoins again, and then actually read the Bitcoin white paper and actually get hooked into it. I finally understand the magics of the decentralization, the concerns, the proof of work concept. So that's how I entered into the blockchain industry. And then after a few years, there's a Polkadot and Substrate that come out, and we want to build our own blockchain as well. So I study Substrate and actually building blockchain using it. I think it's definitely this journey is definitely a very long and a lot of interesting things.
Awesome. What year was it that you found out you first heard about Substrate?
And I think it's 2017.
Yeah.
Yeah, so actually it's 2000, like probably in the mid 2018. I lost count of time. So I think I started actually using Substrate like late 2018. So it's before the first version is coming out. So there is still a lot of rough edge, like things constantly changing. There are basically no documentations, and all you need to do is read source code or ask one of the devs or how to do things.
Yeah. That's awesome. So we got a Substrate OG and a blockchain OG. Rita, how did you get into blockchain and what was your aha moment?
Well, I have a similar experience with Brian as well. I heard about Bitcoin a long time ago. I was actually thinking about mining them back then when electricity still, I mean, what I conceived at that time was that it's essentially exploitation of electricity. I didn't get an idea of like this could be valuable. But if I did go to mine back then, I was still so out of Bitcoin, so it would be even worse regret. Well, the aha moment of like, why do I think this technology is so revolutionary is that I think the first time you as an individual is able to own an asset on the internet. So I've been talking to people like whatever in your phone, you don't actually own any of the stuff on your phone. Your email might be owned by a service provider. I mean, likely Google, your Facebook account, your Twitter account does not actually belongs to you. Well, but Bitcoin or any sort of like blockchain asset is the first asset that you can truly own as an individual. So that's the aha moment for me. And from that, there's this idea of like smart contract, the disintermediary, and I think it's just the future. Like we can already glimpse what's the future is going to look like with this sort of technology.
That's awesome. It's always interesting to see what brought people into the space. Some people come from like the business side or the technology side, and like self sovereignty was like a huge part of the aha moment for me. And it's always like asking folks that.
Yeah.
So I know you guys are both based out of New Zealand. So like, tell me about like how you guys met and like how long ago that happened.
Well, I started to get into the blockchain sector about 5 years ago when I fully committed to the blockchain sector. Well, and about a year and a half ago, I think it's really important to build something that can create value. And at that point, I was looking at the blockchain sector. I think finance is probably the first sector that's going to have some solid breakthrough using this decentralization technology. What people have been talking about, any sort of stuff can happen on blockchain, will happen on blockchain. I do believe that, but I think it takes time. But finance is different. So with finance built on top of blockchain, you can already see huge value out of that. So for example, a decentralized bank similar to Compound has already been built, stuff like that, like really being beneficial for the end users. So that's why I decided to start a new venture. And I'm fortunate enough to be able to meet Bryan in my previous venture, and we talk about, hey, what's really important, like what should we really commit to build on something. And I mean, we share the same sort of value with pretty much all the co-founder in these ventures. And it's just, I would suggest that we are lucky enough to be able to come up with these set of founders in a small country such as New Zealand.
Awesome. That's super cool. So you guys met, you say like a year or two ago?
No, actually, we worked together like about 3, 4 for about more than 3 years, and we started to we started to commit to our own venture maybe a year and a half ago.
Right. That's awesome. And so you guys knew each other and you started talking and you wanted to build something. And then
Mm-hmm.
you, I know you guys both, you founded two companies together and you
Mm-hmm.
decided to build, we're going to ask about those companies, but you decided to build it on Polkadot. So
Mm-hmm.
tell me about like that journey on how you arrived on the Polkadot as a platform.
Well, I'm gonna just share high level detail, and Brian can chip in the actual technical side. So we see the bottlenecks that we foresee the bottlenecks coming on Ethereum. But we were thinking about, if you want to build something finance related, it has to be scalable, and we're looking through a number of options there. Polkadot is not only scalable; it actually give us more flexibility in terms of like what we are able to achieve to build on top of it. So that's the idea, like why we should build on Polkadot. Brian, would you like to chip in your thoughts?
Yeah, so from a technology perspective, like when we were trying to build a blockchain project, also, and we researched quite a few different options. So obviously, Ethereum Solidity is one of the solid options, but there are way too many limitations that you can only do certain things on Ethereum. There's gas limits, like there's a lot of things you cannot customize for. Then there's other blockchain building frameworks, for example, the Cosmos SDK. With that option we also evaluated before, but in the end we figured Substrate is one of the best. It's the best blockchain building framework for us. There's few reasons. That one of the important reason is come with the ability to perform runtime upgrade. So basically, or in other words, forkless upgrade. So you can update your blockchain logic concerns like the actual code without doing a hard fork. So this is quite critical features for all the blockchain projects, because it's really hard to get everything done correctly on the first try. So we obviously want the ability to upgrade our software or adding new features, fix bugs. Without the ability to do this focus upgrade, then we need to, like, for some projects, they basically just do hard fork every 6 months, which sort of works, but obviously it's not the best way. They do hard fork because they have to, not because they want to. So we have Substrate providers features solve this problem. Also, the team behind Substrate is a party, so they build party Ethereum node, obviously one of the largest Ethereum node. They build like Bitcoin node, Zcash node. So they are one of the most experienced blockchain building teams out there. So we have pretty good confidence that they will be able to build Substrate and Polkadot.
That's amazing. Yeah, it's we had a talk earlier about onboarding and getting people into the blockchain space, and I think a lot of the time we focus a lot on getting like investors or just general people to use blockchain, but there's a very interesting and necessary onboarding of developers to use their to use blockchain technology. And I think, yeah, you just demonstrated how like a value proposition of Substrate being easy to implement an idea and change that idea easily without having to without creating friction points in creating hard forks and stuff like that. So that's awesome. So let's talk a little bit about Acala and Laminar, your two projects. What I know we're gonna go a little bit deeper into Acala when we start the talk, but give us like a quick overview and what's the difference between the two and how do they kind of connect?
Well, yeah. So when we started this venture, we think about that whatever we do, it has to be finance related because that's where we see gonna create values in the near future. So we started to looking at Polkadot and we think about, hey, what do we need to build on Polkadot to make DeFi available or viable on Polkadot? And obviously, the first pieces we have to build is like a decentralized stablecoin, and that's pretty much one of the core offering of the Acala network. Deep in its core, the Acala network offer a decentralized stablecoin built on top of proof stake network. You also offer a number set of other financial primitive when we're getting a little bit more detail later. But I mean, down its core, it's a stablecoin. And then once we have the stablecoin, we're thinking about then how quick can we create utility out of this stablecoin. So we're thinking about the one of the most popular market in blockchain space is trading, especially leverage trading, and that's why we created the Laminar protocol, which allow pretty much anyone to speculate on asset, a mature asset, in a leveraged way, which are actually holding the underlying asset. So you can see these two protocol they work with each other, right? So the stablecoin creates utility value out of like your valuable crypto asset. For example, you can capitalize Bitcoin to create stablecoin, and then once there's a supply of stablecoin, trader can use it to speculate and trade. It's not only for speculation; it's actually quite useful as well. Think about a decentralized Big Max. I mean, a lot of traders is able to get utility value out of the synthetic and margin trading, either going to be like trading, hedging, or an option or things like that. So that's pretty much like what we created for these two protocols.
That is amazing. I already have a few questions, but I'm gonna save them for the Q&A towards the end. I think we're gonna move towards getting ready for our workshop. But before I do that, I want to make a special announcement because you can see I'm wearing my Polkadot shirt today. Brian and I are both. Yeah, we're all wearing our Polkadot shirts. Brian and I are both. We're both Polkadot ambassadors, and I'm just trying to share my screen while I talk at the same time. Give me 1 second here. There it is. Where'd it go? Sorry, guys. Okay, I'm gonna do this. Can you guys see my screen?
Oh yeah, coming out.
Coming, yep.
And you can see Hello World?
Yep.
Awesome, cool. I want to give a huge shout out to Polkadot, who has partnered with us during this hackathon, but who are also holding a hackathon of their own. And it's actually a very new, a very intricate nuance on the hackathon model. So instead of doing the traditional thing of like pitching separate projects against each other, they have several different levels from beginner, intermediate, and advanced, as well as ecosystem partners, ecosystem challenges, and there's a limited amount of submissions for each one. So if you complete the challenge, it's kind of like a bounty, but it's different. It's a mixture of and a refreshed view of the hackathon model. So I'd like to really encourage you folks to check out Hello World. It's being managed on Gitcoin, so you can go check out their Hello World by Polkadot, and you can level up your skills there and then bring them back to Blockhack and build a business using those skills. So I wanted to send a shout out to those guys. And of course, I just got my Polkadot shirt. It arrived just in time on Friday, so I was super excited about that. And now here we are. Okay, so we're going to jump into the talk, but one more thing that I want to mention before we do that is for the folks that are in the audience, there is going to be a workshop section shortly after Ruitao does a deeper overview of what Acala is. So if at any point in time you have questions, please use the Ask a Question button. And if you see a question there that you want to get answered, make sure you upvote it so we can get to the most important questions for you first. And right beside the Ask a Question button, there is a polls button. We got a couple polls up there, and let's take a quick look. I see some answers already. So we want to know, had you heard of Acala before today? And we have 57% saying yes, but 42% saying no. So we're about to change that. We're about to give you a little bit of an overview of what Acala is and what's going on there. And we also want to know, have you done any substrate development? And so there's one person that says that they have been, but a lot of folks have not yet. And so we're hoping to change that as well, giving you a bit of an overview of what is actually possible with this amazing technology. So we'll check back in on those polls at the end. But I think that's it for me. I'm going to make myself scarce, but I'm still going to be here in the background. So I'd like you all to help me digitally welcome Bryan Chen and Ruitao. Ruitao is a co-founder of Acala, as well as the CEO of Laminar, a leading synthetic asset and margin trading platform. Ruitao has led the design and development of leading token economic models, including the Decentralized Sovereign Wealth Fund. He has also led multiple successful token generation events and founded several technology startups. And Bryan Chen is a co-founder of Acala and the CTO of Laminar. As a core contributor to the Substrate codebase, Bryan is also an active Polkadot Ambassador, and he is also the lecturer of the first Substrate/Polkadot online course, which was endorsed by Dr. Gavin Wood. I'd like you all to help me in giving a nice digital welcome to these lovely two gentlemen, and I'd like to pass it over to Ruitao to take it away.
Thank you. And actually, just one additional shout out to the Hello World by Polkadot as well. We are actually one of the sponsors for the Ecosystem Challenge. So yeah, do check that out. And I think it's a very good way to get into Polkadot. But without any further ado, I'm gonna actually run the slides and give you an intro of today's workshop. I'm gonna give a very, very high level overview of what Acala is in a for less than 5 minutes, and the actual hardcore stuff is actually coming from Bryan. Bryan gonna actually share the experience of like how to build a decentralized exchange using the Substrate framework and using some of our library that we created and stuff like that. So so I don't think there's additional introduction needed for me and Bryan. Bryan is one of the co-founders for Acala. I'm one of the co-founders for Acala. The agenda today is pretty much I'm gonna give a little bit overview, and then Bryan gonna get a hand dirty and provide a deep dive in the tech stuff. So the Acala overview. What is Acala? So the Acala is a parachain on Polkadot. The concept might be very, very new, but I'm thinking about giving an analogy here. So on Ethereum, which is probably one of the most common smart contract platform out there right now, you build dApp. Pretty much like you build application and you deploy on Ethereum. You got pretty much decide what happened within your application, but outside your application, you have pretty much no control on how the actual chain works. You cannot control the gas fee. You cannot control the core level stuff. Those is determined by the Ethereum. And on Polkadot, this actually changes. It gives you one level more of flexibility. So instead of building dApp on Polkadot, you build blockchains. One of the challenge that for teams that would like to build a specialized blockchain, usually they were facing a number of challenges. One is that it's extremely hard to build a blockchain from ground up. And also, once you build that blockchain, it's extremely hard for you to source security. So people can trust that this blockchain itself is decentralized enough to provide security needed to transact on top of that. Polkadot actually solves both of the problem. The first problem Polkadot solves is that giving you Substrate, which is a framework for you to come up with your own custom blockchain. with just few line of code changes. And the other problem that Polkadot solve is by a very smart economic design that you are able to use the shared security of the Polkadot network. For now, I think it's over $4 billion worth of security, which is very, very secure. So we take this opportunity and we created Acala. Acala is a specialized blockchain connecting to Polkadot and Kusama. It is a blockchain by itself, but it also has a built-in set of protocol to provide financial primitive to happen on top of Polkadot. So it provides a stablecoin, a decentralized exchange, and it also provides a staking derivative protocol. And all these protocols, they work each other to facilitate what is needed for DeFi to happen on top of Polkadot. With this primitive protocol built in, the Acala itself is also an application platform. That means Solidity smart contract, Ink smart contract, or even core module could be deployed on top of Acala. So I would like to see other developers to take advantage of what we built and pretty much extend that functionality to even more users. So down into the hood, Acala provides 3 core protocols, as I mentioned. So the stablecoin protocol itself is a multi-character stablecoin, so pretty much very similar to MakerDAO. It's MakerDAO inspired. You can characterize DOT, Kusama, Bitcoin, or even more valuable asset, and to create a stablecoin, which we call AUSD. We believe that there's going to be a variety of assets that's going to be available on Polkadot. As far as we know, there's a number of teams that's already building bridges to Bitcoin, bridges to Ethereum. So we think there's going to be abundance of valuable assets, and all those assets could be at some stage plugging into the Acala project and be used as crypto. And because we pretty much get to customize the rule for this blockchain, we're actually able to make a lot of very, very user-friendly features, such as like when you actually transfer USD in this particular project, you don't actually have to pay a foreign token. You can actually pay AUSD as the gas fee, and pretty much the AUSD, the stablecoin, is pretty much the de facto standard stablecoin on the Polkadot ecosystem. And obviously, we also built a decentralized exchange built in. It is not only a decentralized exchange, it's also a unified source of liquidity. By having a unified source of liquidity in the blockchain down to its core, we're able to provide what I mentioned earlier, is able to provide flexible fee payments. It also gonna provide a better security, a more safe design for the stablecoin as well, because liquidation could also happen automatically through the unified source of liquidity. And ultimately, we also build a staking derivative. So pretty much a trustless staking pool that user or traders, they can mint L dot token by depositing their dot, or mint L KSM token by depositing their KSM. So think about an L dot token is like the yield bearing token for Polkadot. By staking directly with Polkadot, you will be bound to the 28-day unbounding period. But by staking with this protocol, you can have a staking derivative that you are free to trade and exchange. And the most important is that this derivative can also be used as crypto. So when you are creating a loan, you no longer need to give up your opportunity cost. That would be like your staking reward. So the reason that we build this set of primitive together is that I think they are the minimum viable set of protocol in order to achieve a stable coin on Polkadot. So those is the number of primitives that we built together. And beyond that, it's by itself, it's also an application platform. So working with a number of projects, so the developer can deploy Solidity, Ink smart contract, and expand what we have built. There's an overview of like the teams or the project that we're able to work with. We are fortunate enough to have a lot of partners and developers and ecosystem partners to build this network with us. We have been running the testnet for over 4 months, and we have a great community following as well. Everything that I mentioned is pretty much already in a code complete status. Feel free to visit our testnet and visit our documentation. We also have a huge community, a very, very good community to talk with, to work with. We are looking to go live on Polkadot very, very soon once the project functionality is ready. For now, we are undergoing a security audit, and I'm very, very excited to see what the DeFi space is going to look like on Polkadot. But without further ado, that's pretty much just a high-level review for what Acala is. I think the core topic for today to talk about is to talk about how we actually build a blockchain. So the actual workshop stuff here. So I'm gonna hand over and stop sharing my screen and hand over to Bryan, who's gonna share his slides.
Yep, thanks, Ruitao, for the intro. So, yep. So let's start the actual workshop part. So just a quick agenda. So we're going to build a sample order book specs exchange. So people can submit orders and others can take orders. So it's like most the simplest decentralized exchange, obviously built on top Substrate as well as open runtime module. So it's the open source library that we have developed. Provide a bunch of common functionality that not included in the core Substrate framework. So in this workshop, I'm going to provide some tips and tricks for writing a high quality and high performance frame runtime. So like some things that you're probably not going to know unless you've facing the performance issue that we have faced before. If we still have time, then I'm going to provide some walkthrough of how the ORML is being used by Acala, so how we're actually using it. So let's start with the demo of like what we are going to build. So I currently have this node running in background. So this is a Polkadot JS apps. So it's basically the mobile the browser workloads and how you're going to interact with the blockchain. So this so there's a chain state. So this allow you to browse the blockchain state. So we have like the tokens. So I can query the balance of the accounts. So you can see this LS have 10 dots, have 10 Bitcoins. We have Bob, which also have the same like 10 dots and 10 Bitcoin. So we're going to make a transaction. So transaction is called extrinsic in Substrate. It's something from externally. So hence the name. A transaction is usually signed transaction, but there are other kind of transactions. So hence they're calling the more generalized than extrinsic. So using the exchange that we're going to build, the user will be able to submit order or create order. Say I want to have making trade, so I want to use 10 dot to trade for 2 Bitcoin. So I can submit transaction, sign and submit. So it takes 6 seconds block time. So it's been confirmed. You can see in the event that there's a new order is being created. So as the Bob, and then I can take the order. So order ID is 0, as you can see here. So I can just take the order. And then now the order is executed. Now if you check the account balances, you can see now the Bob have 20 more dots, 2 less Bitcoin, and LS have like 10 less dots and 2 more Bitcoin. So yeah, this is how then both users make a decentralized trustless trade with each other using this exchange palette that we're going to build. So now into the actual coding part. So actually, before the coding, I want to talk about how to design this palette. So it's quite important to make sure you know what you're going to build before you start actually writing the code, because otherwise, well, if you don't know what you're going to build, then what you're going to write. So for Substrate palettes or Substrate runtime modules, there's a thing called calls or transactions or extrinsic. So they are basically the methods that the palettes expose to the outside world, the ones that others can call, the users can call by submitting a transaction. So they are the public interface of this palette. So as you see, we're going to have a submit order. It's going to take some parameters. So the currency ID, the currency I want to trade, the amount, how much I'm offering, the target currency, what currency do I want to get in return, and how much I want to get in return. So let's submit order. Let's take order. So it's basically the user want to take order. So which order I want to take. So which order, one user will submit order, another user will take this order by trade against the order creator. So there's cancel order. So for whatever reason, the user might be able to cancel the order, so they can just using the cancel order to cancel it. So next thing is bunch types, the data structure that we want to have. So obviously we'll probably want to have an order struct that is basically the same as the parameter of the create submit order. And there's additional field, the owner, so it records who is the owner of this order. So only the owner can cancel the order. And when people are taking the orders, they know who they are going to trade with. So that's the data structure. And the storage are the on-chain state that we're going to actually save on the blockchain. So the runtime logic is going to, all the runtime module is all about like modifying the blockchain state or the storage. So we're going to have a map, mapping from the orders is a mapping from the order ID to order. So people can basically, so this is save the orders and people can query orders by the order ID. And we're going to have a next order ID so that we know when we're creating a new order, what is the order ID for it. And there are some events. So events are the public interface for the SDK or the front end. So when something happens, they can using the events to monitor the state. So it's quite easy. Then we just basically have one event for each course that we're going to have. So when the order is created, when the order is taken, when the order is cancelled. So to put everything together, that is basically the design of this of our exchange palette. So so before the more details, we also want to support multiple currencies, but it's not that easy on Substrate by default because the Substrate itself is designed for one currency. It's provide a good support for one currency, but it doesn't provide a built-in support for multiple currencies. So there's something we need to improve. So that's why we're building an ORML, which I'll be talking about more later. So by using, there are multiple options that we can use. So one is using the multiple instance of the phrase balance palette. So the balance palette is able to deal with one currency. If we can have multiple of it, then we can deal with multiple currencies. But there's some issues because the first, you can only have fixed amount of assets. Like to add a more instance of a balance palette, you need to actually go to the code, add a bunch of lines, create a new instance and compile and runtime upgrade. So you cannot just submit a transition to add a new asset. You need to actually modify the code and perform runtime upgrade, which might be fine for certain case. For some blockchain, they have only limited amount of assets, that may be fine. But for example, if for exchange, they might support like, I don't know, 50 different assets. That's not going to work. And this wizard only has support limited number of assets because there's some limits on how many instances a palette can have. So the frame or Substrate itself provides the assets palette. It provides some basic asset management features, but it doesn't have good compatibility with other palettes. So for example, you cannot be used with treasury or staking without writing additional code. So itself is currently not yet production ready. In that sense, it's not being ordered. There are a bunch of things are missing. So if you're going to launch a blockchain next week, you probably shouldn't use the assets palette. But the upside is there are some working in progress to change the situation. So to add much more features and also bring up the assets to a production ready state. So once this is done, then this will be much better to use. So there's also previously there's a generic assets palette, which probably I'm going to skip it because it's been removed from Substrate 2.0. So unless you've used this previously, you probably doesn't need to know this about anymore. So finally, it's the solutions that are provided by the ORML. So it's ORML is the open runtime module library that we developed. So it's all open source GitHub. So it provides a multi-currency trade abstraction. So it's basically an interface that deals with actually multiple currency. So in Substrate, it provides a currency trade that only deal with one currency. So multi-currency is basically the multiple version the version supports multiple currency for the currency. So all the code in ORML are designed minimum by default. They don't have any extra methods that user may not want to have, but it's super easy to extend. Like for example, in the tokens palette, it doesn't support the ability to allow user to create a new asset, but it's only a matter of like probably 10 lines of code to add this feature. So all the ORML code is under so they will make sure they are production ready because we will be using them on our production code. So the more details about the tokens palette. So it implements a multi-asset similar to the assets palette, but asset palette provides a lot of other features that people may not want. So tokens doesn't have those features, so it's minimum. Like for example, you cannot create a new asset. And we have a bunch of adapters implemented, so they are compatible with all the frame's core traits like currency. So any other palettes that are using currencies, like for example, staking, treasury, then you can use an adapter to have the tokens work with them. And then a bit more about currency palette. So the tokens palette is designed to store and manage multiple tokens. The currency palette is designed to manage the tokens and the palettes balance together. So it's basically the glue between the balance palettes and the tokens palette. Why do we need this thing? So it's for a new blockchain project, a substrate-based project, you probably want to have balance palette include because it comes with like all the existing tools and like for example the wallets, the Subscan or Polkadot, the blockchain explorers, SDKs, etc. They are designed to work with the balance palette. So if you're using a balance palette, then by default you come with some basic functionality support for it without extra work. So we want to use the balance palette, but at the same time, we want to use in ORML tokens. It will be a bit tedious if your code is doing like check if the balance you deal with is the native currency, use the balance palette. If otherwise use the tokens palette, then you're going to have this kind of if else all over the place, which is not good, obviously. So that's why we are going to have the currencies palettes that do the check for you. So itself internally is using the ORML to handle other assets, but for all the operations, transfers, mint, burn, etc., it will delegate to the balance palette for use. So in terms of the users or the developers, we only need to deal with one palette without deal with the both the balance palette and the tokens palette. So let's start the actual implementation. So there's the official node template. Will be the starting point that we're going to use. So you can just click the use this template and create a new repository, and then you are good to go. So a next step will be adding the ORML palettes, the tokens and currencies that I just mentioned. And I guess I should just start writing the code instead of going through the slides. So we're going to want to, so this is the node template. So you can just run just cargo run, and then you can have a node running. So, but we're going to actually start writing some code. So firstly, we want to add the new dependencies. So all the ORML palettes, they are published on Craze.io. You can just search ORML and see all the published ones. Or if you go to the docs.rust, so you can just see all the documents for them. Or otherwise, you can just go to the source code and just read the source code. They are not that hard to read once you understand the basic substrate details. So the cargo tone file is the one manage all the dependencies of a Rust project. So it's something like the package JSON for NPM. And so we want to just add the new dependencies. So just ORML currencies and tokens. So you need to have the default feature equal to false. because it's building for both the Wasm runtime, the one allows the forkless upgrade, and it's also the default is STD, so it's for native execution. So if you don't have the default equal to false, then you're going to have some mysterious compile error. And STD is only enabled if the STD flag is or STD feature is enabled on the runtime. So that is basically declare the dependency, and then we want to actually add the palettes. So let me see where is the best place. Yeah, construct run. So in here you can see there are a bunch of implement palette trade for runtime. So they are the configurations like providing the types and other things. So we will just want to add something for the tokens. So you can check all these details from the Rust document, or you can just read the source code. So there are a few types we're going to provide. One is the event type, which is generated by this construction micro. So it's just same as others. The balance type. So balance type is we'll be using the same type as the palette balance. So this is declared as the U128. So it's a 128 bits unsigned integer. So we're going to need the amount type, which is a signed version of the balance. So in this case, we're going to make a I128. So the signed version 128 bits integer. So we also need a currency ID type. So currency ID type can be different things. So for example, it can be could be a U32 unsigned string, unsigned integer. So it's just a number. But in this case, we're going to do a bit more fancy. So we want to make an enum. So the users to know exactly what are the available options. So otherwise, if it's just a number, then if you want to make a trade with dot Bitcoin, you need to know dot is 1, number 3 is Bitcoin. It still works, but obviously it's not that nice. There are a bunch of derives that implements the basic functionalities. Like encode, decode, they are used by the party scale codec. So the compiler know how to serialize the thing, and same for the serialize and deserialize. So they know how to serialize this into JSON, and bunch of other just basic derives. So in order to use those derives, we need to use them. And there's also another runtime debug they want to use. So that's basically how you add the ORML token. So now if I run, then we're going to have runtime with the balance palette and tokens palette. So as I said before, we want to use the ORML currencies. So the code doesn't need to deal with both of them. So we have the ORML currency tree. So the multi-currency implementation, we're using the tokens as a multi-currency implementation. The native currency implementation, we're going to use the balance implementation, but we're going to use this adapter so that to make this thing they talk to each other. So we need to use the adapter. And we also need to tell the currency tree what currency ID is the native currency ID. In this case, we just say the native is the native currency ID. So internally, this way does is basically check on, for example, transfer or other things. You check. Actually, I just see the code. It's easier. So yeah, if you do something, if the currency ID is a native, then using native do the things. Otherwise, using a multi-currency do the things. So it basically does all the if checks for you. And then the last step will be actually declare the new palettes in the construct runtime macro. Yep. So this is basically how to add this into a runtime. That's all the code need. There's another small things we need to do is modify, update the transparent. So that the transport is basically the Genesis. Well, the name is called Genesis config. So the configuration for the Genesis block. So using default, that means, so for example, the balance, you can see each account is endowed a bunch of money. So we have a bunch of accounts that have money to do the transactions. So we probably want to do a similar thing for tokens. So our accounts come with pre-fund. Otherwise, we will need to using the to-dos palettes to mint some more tokens. So it's easier just have a token pre-mint. So we will need to have some more import. So we need to import the tokens cover currency ID. Oops. And instead of just default, we will do this. Oops. So just the token cover. So we will take all the endowed accounts, find of them for each flatmate. For each of them, we're going to give some dots and some BTC, and the amount will be this number. So the decimal place by default is 15. Well, it's not code anywhere placed in the blockchain level because it doesn't need to. So it's the front end. Like if you don't tell what is the decimal, it will assume it's 15. But it will be more better if you just told the decimal place and the token symbol. So we can do this by define the values. So we need to add a dependency first. And then in the config, we can create some token properties. So there's a properties. So we say the token symbol in this case is test. So it can be anything. The token decimal should be 15. Like again, this can be other numbers, and then it will change how the front end or the SDK handles it. And we want to make a property pass the properties to just declared. So now if you run the node, then the front end will be able to know the token symbol. In this case, is test, and the decimal is 15. This is basically how to create a blockchain that supports multiple currencies. There are some, so if I can run it now, then I basically just have a node with the multi-currency support. So in order to get the front end working, there are some additional types that we need to do. So in the settings developer, so there are some types. Here we need to define other. If I just delete them, or just reset save, it will fail to load because it doesn't know what are the types. So there's a step that needs to be taken. So in here, it's basically say, the currency ID is a enum. Those are the options, and some other alias they will need to provide. The amount is I28. So the next step is actually create the new palette. So instead of the easier way, just copy paste the template palette, and you'll see a starting point. But I will just make one from scratch.
Sorry to interrupt there, Brian. I think your mic is rubbing on your jacket and it's creating like a static. Yeah.
Oh, sorry. Yeah, let me just try to not move too much.
Perfect. Thank you.
Yep. So next, so we need a cargo file for a new Rust crate. So that's the definition. I'll keep this as minimal as possible. So we just set the minimal dependencies and configuration. So we need a source folder contain the lit.rx, which the entry point for crate in the Rust. So again, I'll keep this as minimal as possible. So we need this one to say if we don't have STD features, there's no STD. So it doesn't import all the standard library from the Rust which is not supported in the Wasm. Like for example, there are a bunch of file system handling, random thing, thread handling. They obviously cannot be used in a Wasm environment, so we need to disable them. Some basic imports of the macros, the trait definition, and some declare the storage event error module. So they just like empty implementation. And then the next thing we want to, in a runtime config, we need to import this. And the new palette we just created. And we need to add this one as well. And in the run, similar to add the tokens and currencies, we also need to do the same thing for the new palettes we just created. So in this case, we just have an event type, this one. And so this all the work need to create a new palette and add it to the runtime. But we now have a palette, but it doesn't do much interesting stuff. So this actually write the logic that does the exchange. So first step is I'm going to import a bunch of dependencies that we're going to use. So we're going to import SP runtime. This is the SP stand for substrate primitive. So it provides some basic types from substrate and ORML traits, which is creates from ORML. Again, provide some traits, obviously. So we also need this one. And we also have a bunch of the use that we're going to copy paste here. Oops. So just bunch use that we're going to have, and for the trait, we're going to have some additional types dependency. So first is we need a currency type, so this can know how to deal with currency using the multi-reservable currency for ORML traits. So it's basically a multi-currency with the reserve feature. So itself is like depends on multi-currency, which provide basic functionality like free balance, total insurance, transfer, deposit, etc. And with the reserve add features like to reserve some funds, which is required, like because when you make order, you need to lock up some funds upfront for the people creating the order. So when someone else wants taking the order, like this, guarantee there'll be enough funds to be traded with. We also define the order type ID here. Like this one doesn't need to be like this. It could be just as simple as user2. So this will be enough. I'm just going to show a more generalized way, because if you do this here, it will be hard code. So all the users of this palette cannot easily change this without actually go to this file, change the code. But if we convert here as a trait type, association type, and then it's up to a runtime to decide what is the type of the order ID. So in the runtime, here I can define, say I want to use user32 as an order ID, or I can use U64 or something else. It's up to a runtime developer, not the palette developer. So it's much more flexible. So the currency will be just using the currency from here. Now I can use passing the tokens just like this, but then this won't be able to deal with the native currency. So continue on the implementation. So we will want to have define the order struct, because we so this is basically how you define this Rust struct. Let's have a bunch of generic parameters because they are not concrete. They can be changed in the runtime level, so we cannot just make a concrete type. So they need to be generic type. Bunch of derives, just so like decode, encode, and clone, they just standard thing. And debug is required for other internal macros. You'll notice this using the codec compact. So this is using the compact encoding for the balance type. So because balance is one-to-way base integer, but usually the number is not that large. So it's usually only using the bottom bits of the number. So using compact encoding will only encode using as much space as required to save the storage size. More alias type. So you will see we haven't defined the balance type here. We haven't defined the currency types here because they are indirectly defined by the currencies type here. Because this one come with the currency type and balance type. So in here, we just basically say using whatever the currency type defined by this currency trade as the balance type, using whatever the currency type as this currency ID of. And by this order struct have 3 generic parameters. So every time you use it, you need to a lot typing basically. So this is a shortcut to keep it short. And then we can use our storage. So the first is the orders. It's basically the order ID points to the option order of. So it's using option here because it's possible people just passing a non-access order ID. So this needs to be option. And the next order ID. So there's a hasher here. So it's required by the substrate macro. So you know how to securely hash the thing because this order is a sequential number. So it's not something user can arbitrarily create. So it's using to use the fast but insecure 2x64 hash. And there are some events that we want to have. So in this case, we have the order creator event. So those are things that to tell this declare event macro what are the types. So this format is a shortcut of this format. So if it's like this, then we don't need to have this part. So it's basically say this is the order ID type using the trait defined in the trait, which is this type, and the order type, which is using this one. We're going to have another error that might be created. So just declare it here. So let's start the implementation of the condition. So we'll have the submit order. The origin is if you have done Solidity development before, that is something like similar to message.send, msg.sender. So the one who's sending them transition. So because in Substrate, this one can not necessarily assign transition. This could be unsigned transition, or could be inherited. It could be a transition issued by other origins, for example, the root, the one from the sudo with the admin permission. So in this case, we need to ensure sign to only deal with the signed transitions. If this is something else, then this will going to fail. The question mark is that early return on error thing. So it will return early if this failed. And then the rest of things. So one thing we want to do next is read the next order ID, use it as the order ID, and increment this number by 1. So the next order ID after this one, we're using the correct number. But doing the increments on numbers can overflow. So hence why we have this order ID overflow error. So we need to deal with that. So that's why we're using the try mutate methods from the next order ID struct. It's basically, we do try to mutate this, and if this failed for whatever reason, the storage won't, the number won't be updated. So this is a reference type. So we'll take default reference. It takes the order ID type, create the order, and we want to increment the order ID. So in this one, it's using a checked math to make sure it's kind of overflow by 1, because an ID type is a generic type association, so it's using the special thing to create a 1. Like another way to do it is 1 dot into. This will also work as well. And this one will return option. If that's overflow, it will be none. So it's okay or. So if it's none, then it will say, this will fail with this error. Otherwise, this fine. Then you just assign this to the ID. So this is a reference type, kind of like pointers. So you do assign this value back to the ID. And after this method returns successfully, then this will be write back into the storage. If this failed for whatever reason, this won't actually be updated. So we're going to reserve the amount from the sender, which this could fail because like people can say, I want to spend $100, then maybe they don't have enough money. So this may fail. And this will return early or fail. So if code goes here, that means the reserve is successful. The user actually have this money and they are locked up for this trade. So we can create the order. We can deposit event and return OK. So that is basically the code for create an order. Then the next step will be allow people to take the order. So again, there are the more dependencies that I want to use. So I'm going to use the utility straight from ORML. Again, just the same thing, just add std to here. There are a bit more things I need to use, I just put here. And there are some new events that we would like to emit. So we want to emit the order taken event, so which comes as a parameter of account ID. So we need to provide the thing to tell the account ID's first type. There are 2 more kind of error that could happen. Clear them. And then into the actual implementation. So so define the take order. So the parameter just the order ID. We want to take the one order, see if this exists or if it's valid, and try to execute against the order. So we'll be using the try mutate access method from the orders storage. So this is very similar to the try mutate. The difference that try mutate always assume the thing exists, which it does for storage value. But storage map, it might not exist for a given key. So this one will handle the case. This can also be used to try to delete the thing. So this is one line code that does a lot of things. So it will take, so this type is optional reference. And so it will take it and put the thing inside this order type, and which will basically delete the thing from here. So that means once this commit successfully, the orders for this order ID will be deleted. It will check if this thing does actually exist. If it does not, then return this invalid order ID error. And the next thing we'll do is basically actually execute the order. So I would like to transfer the money from the taker to the order owner with the target currency and target amount. Again, this could fail. So there's a question mark here, which will make us return early on error. And I need to, because previously the fund for the order creator is reserved. So I have two options. I need to either unreserve it first and then transfer, or this repository reserved method that does it at one step. So basically just move the reserve fund directly. So it's basically the same thing. Move the fund from the order owner to the order taker with the base currency and base amount. So the fund is going to move into the free parts of the account balance. So it's freely transferable for the order taker. One small catch for this method is it doesn't return error if the fund is not enough. So instead, it will say how much fund is not transferred for whatever reason, because the reserve fund is very unlikely to be changed, but there are still edge cases that might be get slashed for other reasons. So we need to check this is zero, otherwise it's the error. And then I just need to depose the event, and this is the implementation for the take order. Except there is a one small catch, or not so small catch. Substrate itself doesn't come with the revert state on error. So in Solidity, it's so common that you just throw error, revert, or whatever. If something doesn't work out, and all this transaction will be rolled back. But because Substrate is so customized, it cannot do this because there's the charge of the transaction fee cannot be rolled back. Otherwise, you're basically paying free and nothing to consume the computation of the node. So it doesn't have the automatic rollback feature because the charging fee feature is not standardized things. Different blockchains may have their own custom charge fee logic, and it just cannot be generic ones for all blockchains. So it doesn't have the rollback on default feature. So but in this case, we want to roll back this transfer if this failed. Otherwise, will be one guy takes money, other guy doesn't take the other part. So that's where this is a new Substrate 2.0 feature. So we have this with transition method. So this one is come from the ORML utilities. Which itself internally is calling the with transition from the foreign storage. The with transition method requires a return type of transition outcome is a enum. There's slightly bit more code to use. So the with transition result is basically a wrapper over this method. So it reverts on error. So with this one, then this method suddenly becomes safe. So this will try to transfer. If this success, you try to do this. And if this failed, everything inside this thing will just get rolled back and nothing will be executed. And this will return the error to return whatever error this returns or this returns. And error will go to here, say, this will fail, and pop up to here. So this will not be modified. So this is the implementation for the take order. And the last things we want to implement is the cancel order feature. That would be much easier. So again, we have new event, we have a new error, and we have a new cancel feature. So just take all the ID and cancel it. So this would be very similar to the take order. We all want to try to modify and remove an order. So we'll again using a try mutate this. We will just try to take it and check if it exists or not. And then we need to verify the owner is the transaction sender, so you cannot cancel other people's order. And finally, it will be just deposit event, order canceled, and okay. So that is the cancel order implementation. So this will check if the order exists and if there is owner, and if everything runs with the okay return, and this order, because it's taken, So this will commit the write, which will delete the order for this order ID. Yeah, I think that's all for this workshop, for this pilot exchange. All the code is available in the GitHub, which you can just check out yourself. And if you want to read a bit more about each steps, you can just see the commit history, which is basically what I've done. Yeah, the one final thing is you need to add the new types definition if you want to try it in the Polkadot apps. So there's a compact balance type here, which means the balance type is compact encoded. If you just pass in a normal balance without a compact thing, then it will fail with mystery errors. Yep. So that is all the workshop sharing from me.
Wow, that was packed. I'm definitely gonna need to rewatch that. And I don't know if you noticed, like my laptop, my internet like died partially through, and I was like so worried that the stream was gonna stop. I had to like restart my computer and come back in. So
Okay.
I'm glad. I hope nothing caught fire while I was gone. But yeah, so I caught back up. But yeah, I'm gonna rewatch that. It looks super amazing. So I take it you've been a developer for a while. So you look like a master out there. Like I'm a web developer that's getting into blockchain development as well. So from what I understand, the coding language is called Rust for Substrate. What has your experience been like dealing with Rust specifically?
Yeah, Rust is it's an interesting language. It's one of the harder language, one of the language with very steep learning curve. But it's also one of the most loved language according to the Stack Overflow survey. Yeah, so it's not easy to learn Rust, but once you get know it to it, like it is definitely my first choice language for a lot of new projects.
Nice. Do you have any kind of resources for beginners learning Rust, or would you say just jump in and start doing substrate development and learn that way?
Yeah, the Rust, they do have the official tutorials are quite good. So that would be obviously one of the best way to learn Rust. Also, for me myself, I didn't learn Rust. I just learn Substrate and learn Rust at the same time. So this, for some people, that might be the better way. But obviously, you probably want to have a relevant experience. Like, for example, if you're already familiar with C++, you already kind of get used to all the typings and the lifetime reference, etc. And then you probably can just start learning Substrate without just spend too much time just focusing on Rust directly.
Awesome. Thank you so much, Bryan. That was amazing. I'm not sure if Ruitao is still with us, but there are a couple of questions from the audience. One was specifically directed at Ruitao, but I think you might be able to answer it. But there he is. Yeah, so the question here, and I think you already you answered it in the comments, but we'll ask it out loud just for the sake of the stream. So you mentioned earlier that your software is basically ready to go. The question was like, why isn't it live yet?
We are working very closely with the Web3 and Parity team. We're waiting for the Parachain functionality to be tested and ready, which should be very soon. We're preparing for that. Once the Parachain bonding process and the auction process is ready, we will be going live in no time.
Cool. And so like a follow-up to that is, are you planning on going directly to Polkadot first, or have you done testing on Rococo? Are you going to go to Kusama? What's the plan there?
So we already have a Parachain bound on Rococo. So that's already functioning. We plan to go live on Kusama first, and then just write the email to Polkadot. Then we'll go live on Polkadot. The reason we go live on Kusama first is that we are deploying the same code bases for two networks. So we'll be treating the Kusama deployment as a canary network as a more wild version of Acala on Kusama as well. So yeah, it's gonna be Rekuku, which is already live, and Kusama then Polkadot.
Very, very cool. So, can we expect like you? I think you might have alluded to it there. Can we expect some more experimental, different kind of things on the Kusama version, or will it be the exact same code base on both?
I think upon Genesis they are very similar, and how it evolve after Genesis is up to the community to decide. Definitely we were gonna have some faster turnaround on, or a little bit of wildness on Kusama, just similar to what we see on Kusama as well. So you can see the unbounding period on Kusama was 7 days. The governance process turnaround was way faster. So we're gonna have something like that similar, but how it evolves beyond that is up to the community to decide.
That's very interesting. Like, so when you say it's up to the community to decide, are you going to have some sort of on-chain governance
Yes,
yeah? Can you talk about that a
definitely.
bit?
So
Yeah.
yeah, definitely. So we're gonna follow the very similar way of how Polkadot evolves. So the token holder would have functionality to elect council members, and there are gonna be a number of council members. We're gonna follow the path of like the progressive decentralization. So initially, the founding team will have some influences, and gradually, as the system matures, we'll see us losing control, which is a good thing, and slowly giving the power back to the community.
Very cool. And so, what token would be used for that? Are you going to use native KSM or DOT, or are you going to build your own?
So the Acala has the on the Canary network we have a token called KAR, and then on the Acala mainnet there's gonna be the ACA token, which is going to be the governance token.
Awesome. Very, very cool.
Mm-hmm.
So there's another question here from the audience. Will Acala support NFT functionality? Do you have any plans for that?
Well, we do have some plan, and it was definitely it will be supported. Actually, this ORML NFT module is already being coded by our team. So we're gonna there say that it's definitely supported. Bryan can probably look in with some details regarding the NFT functionality on the technical side. Bryan, would you like to elaborate more?
Yeah, so like just in a few weeks before, we just developed the ORML NFT palettes, so they allow people to add NFT functionality to the chain easily. And obviously, we are the first chain to try that. So yeah, we're going to have NFT functionality. But again, NFT itself is just like a token, like the T is literally for token. So having supporting a token doesn't mean that much that every blockchain supports token. It's more interesting about how the NFT is used, which is something we are exploring with, and also like working with other projects and peoples to see if we can come up some good use case for it.
Right. Yeah. That was my next question. Is like I think we've become used to NFTs in terms of like crypto kitties and in-game items, that sort of thing. But I think like you guys are focusing on the financial sector, and I think it's a very applicable use case for like bonds and like real estate and things like that. Is that kind of the direction you're heading with this NFT functionality?
But initially, we will be more focused on the casual side, like for example, some like digital assets, instead of some like real estate, the real life assets, because that is quite different area and require different expertise domains, etc. So yeah, we'll be focusing on digital assets initially.
Very, very, very cool. There's one thing I wanted to go back to from the first part of the presentation, Ruitao, when you mentioned that Acala is a stable coin that is crypto backed. It's backed by DOT, KSM. I think you mentioned BTC and another like USD backed stablecoin. Can you talk a bit more about like the concept of that? Because I think most stablecoins we've seen so far have been strictly USD backed.
Yeah, so there's like two types of stablecoin right now on the blockchain space. There's the USDC, USDT, which is asset back. That's what we call. So pretty much the issuer will have the conventional way to prove they have X amount of US dollar on the blockchain on their bank, and then they will minting this stablecoin blockchain. Well, Acala is different. It's like the collectoralized, over collectoralized type of stablecoin. So the value of the AUSD is backed by crypto assets, not just typical any crypto asset, but instead of those mature and has liquidity, has actual solid value one. For example, Bitcoin, Ethereum, DOT, KSM. So we actually think about that. We've been working with the RAMBTC project to bring RAMBTC on Acala. That's one way. There's also quite a number of other teams that's working on Ethereum bridge, that's working on Bitcoin bridge. So those is like they are all bringing different variety of like asset into Polkadot, and not to mention that Polkadot itself has like dots. And I assume that as this ecosystem grows, there's gonna be other solid asset in Polkadot ecosystem natively as well. So as long as there's enough liquidity for that, and as long as the governance process allow that, any sort of asset can be used as collateral, and you can actually see the asset being locked on chain. So there's no trust needed to verify that we have X amount of the protocol itself has X amount of USD. Instead, you will see the protocol itself has X amount of crypto.
That's amazing. I love that. Yeah. Any time we're moving away from strictly fiat backed, USD pegged stability in coins and moving more towards decentralized crypto finance, I love it. I think it's super, super interesting. Okay, do we have any more questions here? Okay, I don't see any more questions, but I'll do a last call. If anyone has any more questions for these amazing gentlemen while we still have them here, I'm going to take a look at the polls while we take last minute questions. Let's see. So we asked folks if they had heard of Acala before today, and a lot of them have heard. 67% had heard, but 33% had not. So now you know about Acala. Now you know about Laminar. You know you got to go do some research. You know we love to use the acronym DYOR. Do your own research, and so now this is on your radar. So go check them out, guys. We have you done any substrate development before? And 20% have done, and they're pretty experienced with substrate. So we have some deep substrate heads in the audience. No beginners, but we have a lot of folks that are pre-beginner. So I hope this has encouraged you guys. I hope you rewatch Bryan's talk, and you can go through that workshop step by step and create your own exchange. I think that's fascinating. We did that in about an hour. Granted, he's an expert, but you'll have the recording to pause and go back and read you at your own pace. And of course, if you run into any issues, please come find us in the Discord channel, and we will help you out with any of those issues. I don't see any more questions, so I would like to thank both you, Bryan, Ruitao, for tuning in today. It's been a very illuminating, enlightening chat, and I think our hackers will get a lot out of it. And again, I want to shout out Polkadot and Hello World, the hackathon that is happening right now. And Acala is an ecosystem partner with that. So go check out their challenges on Gitcoin, and then bring those skills back and come build a business for Blockhack and pitch it, and you can get seed funding, and we can build up the ecosystem together. Do you have any last words on where we could find you or find out more information, Bryan or Ruitao?
Yeah, so we'll be available on our Discord server, Telegram group channels, and I think we're going to share our slides, which should have all the links. So we are also very active on the Polkadot Discord server, which also there's a channel called Substrate Technical. So if you have any substrate technical related questions, just feel free to ask there. That may us or maybe one of the priority developers will be able to help you there.
Perfect. I have just posted the slides there for those that want to follow up with that. And I'm going to post one more link in there, we are continually trying to get better at doing online workshops, and this is our first time doing a fully online hackathon. So we're going through growing pains. We're using Crowdcast for the first time. So please go visit our Airtable, take a minute and give us some feedback on how you're enjoying these workshops, and we're going to continue to get better. But thank you again, Bryan and Ruitao. And on that note, tune in, everybody. Tune in tomorrow. We're starting a brand new, fresh week of workshops and talks. And until then, I will see you guys in the next workshop. Bye, guys.
Thank you.
Thanks.
Thank you.
Bye.
Bye-bye.